Hello everyone. So in this video again we'll take a look at the different kind of question as in terms of integers and number system. The question particularly dealing with number systems in general. So the question basically is, let x equal to set of 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So let s be the element of x such that any non-negative integer n can be written as p plus q when non-negative integer p and q have all their digits in S. Okay. Find the smallest possible number of elements in S. So basically we have to minimize the number of elements in the S itself. So let's start off initially. So let me start off by basically assuming assume 5 numbers will be sufficient. So we'll start off with that only. Okay, so now let S equal to with the set of 0, 1, 3, 4 and 6. So now if I'm supposed to split the following, so we have something like, suppose let me give a few categories as such. Okay, suppose we have the following categories like N, A and B. So observe the case over here. Suppose for N0 we have A0 and B0. Okay, A and B are elements of S. Subsequently for N equal to 1 we have 0, 1, again 0, 1 element of S. For 2 we have 1, 1 element of S. For 3 we have 0 and 3 element of S. For 4 we have 1 and 3 element of S. For 5 we have 1 and 4 element of S. For 6 we have 0 and 6 again element of S. For 7 we have 6 and 1 element of S. For 8 we have what do we have here? For 8 4 and 4, okay, element of S. For 9 we have 6 and 3. So our assumption basically turned out to be correct. 5 numbers are sufficient and the numbers that we have taken are 0, 1, 3, 4 and 6. So what can we conclude from the same? Thus each digit in the given non-negative integer is split and can be written as a sum of two numbers each having digits in S. Okay, now we show that mod S is greater than 4. Suppose mod S is less than equal to 4, we may take s equal to 4 as adding extra number to s does not alter our argument. Okay. Let s equal to a, b, c and d. Since the last digit can be any one of the numbers 0, 1, 2 up to 9, we must be able to write this as a sum of digits from s modulo 10. Thus, the collection so what is the collection over here? A equal to x plus y mod 10, where x comma y are element of x or element of s, must contain 0, 1, 2, ... 9 as a subset. But A has at most 10 elements which are basically 2 plus 4 . Thus each elements of the form x plus y mod 10 as x comma y vary over s must give different number from 0, 1, 2, ... 9. Okay, so let's continue our discussion further. Consider a plus a comma b plus b comma c plus c comma d plus d modulo 10. They must give 4 even numbers hence the remaining even number must be from the remaining 6 elements obtained by adding two distinct members of S. Okay, so we may assume that even number is a plus b mod 10, then a comma b must have same parity if any one of C comma D have same parity C comma as that of A, then its sum with A gives a even number, which is impossible. Hence, C comma D must have same parity, in which case C plus D modulo 10 is even. Which leads to a contradiction. Okay. Therefore, we conclude that mod S is greater than equal to 5. So hopefully this solution to the following is clear to you. So we have discussed in details and broken down everything into small bits so that this can give you a clear idea as to how to go about while solving this particular question. We have initially taken an assumption and given you all the reasons, particularly why the assumption stays corrected, and that assumption stays intact while all the other conditions pertaining to the assumption are null and void. So with that said, hopefully things are clear to you. So with that said, I'm signing out. Thank you so much.